Okay, guys, welcome back. Algebra 2. We're going to be going into Unit 4B today. Today is a refresher of something that you guys learned in Algebra 1. We're going to be factoring quadratic equations and then later on to solve those quadratic equations. So today we're going to focus on two types of factoring, GCF, which stands for greatest common factor, and then halfway through we'll go into our second way of factoring, which is difference of squares. All right, make sure you guys are pausing frequently and taking notes in your notebook. You never know when I make it an open note test. All right, so here's the steps that I'm going to go through today. You probably want to pause and read them to yourselves. Now, whenever we go into factoring, we always want to check for a GCF first in a factoring problem. Now, when I give you problems to do, I'm not going to tell you what factoring you're going to have to do. That's for you to figure out. That's for you to memorize what things look like and the procedures. But just remember, no matter what, when I give you a problem to factor, always look out for the GCF first, greatest common factor. All right. So greatest common factor, I'm looking at example 1 right now. So when we take a look, we have two terms here. This is called a binomial. So look at the numbers of the terms first, 4 and 2. So you're thinking, what number, a factor is a number that multiplies into itself or a higher number evenly without having a decimal or remainder. So what number multiplies into 4 and 2? Well, that's 2. So 2 is part of my GCF, which I put on the outside of parentheses. See, when we do these problems here today, our GCF problems, we're dividing it up into smaller parts, and our GCF is going to appear on the outside of the parentheses. And then we're going to divide and to see what's left over inside parentheses. So also, notice I left some space on this problem between the 2 and the parentheses. That is because we have x's in both terms. So if you have x's in all of the terms, that means an x must be part of your GCF as well, part of that too. So the rule is if I have x squared in one of the terms and x in the other term, remember you take the smallest exponent, the smallest degree. So now my GCF is 2x. Now what I do, I got to determine what's left over in the parentheses, so I must divide each term by 2x. So 4x to the second divided by 2x, well, 4 divided by 2 is 2. And then x squared divided by x, remember the rule is you're supposed to subtract the exponents when you're dividing. So x squared, remember x squared is like saying x over x. And then divided by x, these x's cancel out, leaving you with x left over. So that would mean 2x. Bring down your minus sign. Now 2x divided by 2x. Remember, anything divided by itself is literally just 1. In other words, the 2 divided by 2 is 1, and the x's cancel, if you want to look at it in that way. Okay, example 2. What number multiplies into 9 and 24? What's the biggest number? Don't say 1, it's actually 3 here. So part of my GCF is 3. Should I have an n in my GCF with the 3? Yes, n appears in both terms. And it's showing an n squared and an n. You take your smaller one. And now I'm going to put my 1 parentheses. And then I'm going to divide by 3n. So 9n to the second divided by 3n. 9 divided by 3 is 3. And then n squared divided by n is n. Carry down your minus sign. The 24 divided by 3 is 8, and the n's cancel because they're the same. Now, side note, if you ever want to check to see if your answer is correct, you can take this 3n and distribute it with 3n minus 8. If you distribute correctly and then combine like terms correctly, it will turn back into your original problem. Next, got two terms again. So the GCF of 4 and 2 is obviously 2. Do not put, see the x in the first term? Do not put that x as part of your GCF. And x cannot be part of your GCF here because there is no x in the second term. Now there is a y in both terms, so we choose y. Now we're going to put our 1 parentheses and we're going to carefully divide by what we just factored out. So here, that would be, actually, I'm going to show it a little differently here. It might help you out a little bit if I'm showing it over each of them. So here, we can kind of view it like, okay, the y's cancel out. What's left over? 4 divided by 2 is 2, and carry down the x. In the second one, they divided each other out, meaning, again, 2y divided by 2y is 1. Anything divided by itself is 1. Okay, there is no normal number that's part of the GCF. Technically, this is a 1 here, but if you have a GCF of 1, you really wouldn't say, hey, I got a GCF of 1. You just don't list it outside the parentheses. However, the variables, there is a y for both of these variables. So y to the fourth and y to the second, you go with the smallest one, y to the second. So that's your GCF. And then carefully divide by y to the y squared, if you want to call it that. All right, so what's left over in the parentheses? Carry down the 3. Y to the fourth divided by y to the second. Remember, we're subtracting the exponents. So y to the second. Carry down plus, and then these divide to get 1. The y squared over y squared. Okay, example 5. What's the GCF here? Just be x, smallest exponent, and then divide each by x to have x squared divided by x is x, plus the x squareds cancel, so plus 18. All right, we got a trinomial here. Think of the largest number that goes into 6, 30, and 12. If you said 2, that's not large enough. There's actually a bigger number. It's 6. Now 6 is your GCF. There will not be an x with it. Why? Because there is no x with the 12. So it's just a 6, not a 6x. And then carefully divide everything by 6. So that'll be 1x squared minus 5x plus 2. Okay, I want you to pause this problem now and tell me what you get, or type in what you get for your answer. Okay, so your GCF should have been 7, just 7, and then divide by 7 to have 3y squared plus 1. I should have mentioned earlier that when you're putting like something like a 3y squared, if there is a function in Edpuzzle, if you find it, that does exponents, but if you're not sure where to find it, you can just put this, the caret, the arrow pointing up, that means exponent, and then you would of course put everything around it, okay? Next, try this on your own. Okay, so the GCF should be 4 and x, and then divide by 4x. First term divides to have 2 and x to the first. Carry down the minus and 1. GCF of the second group, there is nothing other than 1 that goes into 7, 9, and 10. The GCF here is just x. We have x to the fourth, x to the second, and x, smallest exponent. And then just divide everything by x, so that'll give you 7x to the third minus 9x, and then plus 10. Notice the 10 does not have the x with it because this x canceled with this x. Okay, the second thing we're going over today is called difference of squares. This is another one that a lot of students get intimidated by, but it's actually very easy, and you guys did learn about it in Algebra 1. It's called difference of squares, also known as difference of perfect squares. So it's in the form when you have x squared, and it must have a minus sign, and then a number that is a perfect square, meaning a number that can, when you square root it, gets a whole number, such as square root of 1 is 1, square root of 4 gets 2, square root of 9 is 3, square root of 16 is 4, and so on. Let me just write the perfect squares up here. 9, 7, 8, 9, 10, 11, and 12. So you should memorize up to those to make life easier on you. So I can, and then when we factor it, we're going to use two parentheses here, x plus a number and x minus a number. And those numbers would be found when we square root. So in example 7, again, I have x squared, and I have a minus sign, which is important, and I have a 16, which is a perfect square. So I know that is a perfect, a difference of squares problem. So I go x plus and x minus, and then I square root the 16, which is 4. So put the 4s here. Again, if you're unsure of that, remember you can always check your answer. Take the x plus 4, x minus 4, FOIL and combine like terms, and I guarantee it will turn back into the original problem. Example 8 is also a difference of squares. 36 is on our list, so n plus n minus, and then the square root of 36 is 6. Okay, example 9 bumps up the difficulty a little bit. Don't get intimidated by the 4 that's in front. All right, pretend if this 4, let's just ignore this 4 for a second. Let's say if it was just x squared minus 49. What would you have here? You would have x plus x minus, and then the square root of 49 would be 7. Now, if you have the 4 in front of the x squared, notice that 4 is a square rootable number also. The square root of 4 is 2, so just put 2's in front of the x's. Pretty easy stuff. So the perfect square number can be in front of the x squared, or it can be by itself after the minus sign. Next is another, just like example 9, another difference of squares. Again, what's new here is this guy, but we just treat it like the a in the beginning. So bear with me here in my explanation. So let's set up our two parentheses. So we know that our signs are going to be plus minus. Let me color code it for you. So the 25a squared in the beginning, the square root of that would be 5a. So put 5a in both parentheses. And then, again, the minus sign's there to say it is difference of squares. But then we have this new 36b squared. Again, treat that like like everything else we've done. The square root of 36 we know is 6, and then just put b's with it. The b squared changes into b's. Pretty easy stuff. Okay, example 11. Notice that 2 and 162 are actually not perfect squares. So this is actually, we're just trying to throw a curveball at you. We actually have a GCF first here. Remember what I said earlier in the beginning of the lesson is always look for GCF first. So the GCF of this is 2. And then we divide by 2 to have y squared minus 81. Notice what that looks like now. This guy here is a difference of squares. So we're going to bring down our 2, and then our y squared minus 81 is going to break up into two parentheses. The y squared breaks up into the y's. We need our plus minus, and the square root of 81 is 9. Okay, take a minute, take about a few seconds actually, and try this one on your own. Okay, your answer should have been x plus 9, x minus 9. All right, take a minute. Be careful, this is a two-stepper, and try this one on your own. Okay, you should have actually had a GCF first of 3. And then divide by 3 to have x squared minus 9. Then the x squared, I'm going to put DOS for difference of squares. X squared minus 9 is a difference of squares. So that should be 2 parentheses x plus 3, x minus 3. And then the last one, try this out on your own right now. Okay, there is no GCF here. This is just a perfect squares problem. It is like example 9 and 10. 64 and 25 are square rootable. So the square root of 64x squared is 8x. Our sign's got to be plus minus all the time for difference of squares. And the square root of 25y squared is 5y. And that's it for my lesson.